Okay, before we continue our lecture, I'm going to ask your permission if for the recording of this lecture. Just say yes and or comment on chat box that you allow me to record your this lecture. Okay, thank you. So we continue. Now, we have this part. So this is a classless interdomain routing. So this allows you to to separate connections and allow you to use the IP address to a specific values so that you're not going to utilize all of it. So that's the purpose of classless interdomain routing. Before then, there is no CEDR notation. So what happens is there is a congestion of IP address. Now with the method, you could be able to reduce the bits and information and allocate IP address to other location also. So what are broadcast domains? So this defines which device must receive a packet, and the that's by any other device, and each part on the router constitute a broadcast domain because routers don't uh, forward broadcast packets. So TCP/IP communication relies heavily on broadcast packets to perform variety of functions. So now we go to this part. So we have the HCP and ARP use broadcast to perform their task. So every time a computer receives a broadcast packet, the network interface card generates an interrupt, causing the CPU to stop, and it's going to read the packet. And usually broadcast is irrelevant, but the packet is usually discarded. Now imagine you have 65,000 computers on the same broadcast domain. So that's why what is important is that the amount of traffic generated, and there's additional CPU utilization likely bring the network screening to stop. Preventing this problem is one of the reasons why we are going to use a subnet. So that's for the CPU utilization and traffic congestion of the broadcast packets. So that's why we subnet. Now, example, given the large network with a network address, one moment, please. Now, if you have given the example 172.31.0.0 and your slash 16, this is your CEDR notation, meaning you occupy So if you have 16, so what would be your subnet mask? So you have 2, so you have 255.255 dot 0.0. So this is your subnet mask given this network address. And then you can divide this very large network into smaller subnets. So for example, you can use 172.31.0.0/24, and or you could use this 1.1.0.24 and so forth up to the 255th. So on each value, you could perform specific subnetting procedures. This addressing strategy is called subnetting. It makes 256 smaller subnets. So as you notice, you start from 0 and you end at 255. So 0 is counted as 1, and this 255 is your 256 subnet. And by the way, you could only use 254 because this is used for your one ID is used for your subnet number, and the other was for your network address. So later we'll have some calculation regarding this. So why we need to subnet? So if a computer on one subnet needs to communicate with a computer on another subnet, the packets are sent to the router that locates the subnet and forwards the data. Now the maximum size of your broadcast domain is only 254 computers, which is more manageable. And another reason to subnet is to conserve IP address. Companies that maintain internet-connected devices need a public internet address, so which must be unique in the world. So meaning a public address can be assigned to one device on the internet. So if you have the same IP address, so meaning your identity can be compromised because he can use your ID as well as you can use his ID also if you have the same address or IP address. So that's why we implemented private IP, and for public, there's a threat of internet access to your information if you have the same IP address. So this is what we call a variable subnet mask. So wherein you are able to prioritize allocation of reservation of host in every computer or every LAN. So as an example, as you see in this figure, so each have this 50 hosts, and you have 30 hosts here, and you have 20. Now, a third reason, that's why we need to subnet, is to divide the network into logical groups. So when one large network is divided in two or more smaller subnets, a router is needed to allow hosts on one subnet to communicate with hosts on another subnet. Calculating a subnet mask. So there are usually two approaches to subnetting, and they depend on the answer to this question. So first, you're going to ask why you need to divide the network. So am I going to provide a network with a certain number of host address, or I am subnetting to provide a network with a certain number of subnets? So if you are working for an ISP, the answer is usually yes to the first question. So I am subnetting to provide a network with a certain number of host address. Now, if you are a network administrator for an organization, the answer is yes to the second question because I am subnetting to provide a network with a certain number of subnets. So because you're going to lessen the number of subnets that you're going to manage. So that's why also you subnet because to lessen the burden of managing the network. And sometimes if you have a large and small network organization, so the answer would be both. So you need to provide network with a certain number of hosts, and you provide network with a certain number of subnets. So those two or both are the answer for subnetting. Now, how do we subnet a large internet network? So first, you decide how many subnets you need. You can figure out the number of subnets by needing to see how many network cable segments or will be connected to the router interface. So each router interface connection indicates the required subnet. Next, decide how many bits you need to meet or exceed the number of required subnets. To calculate the value of number of bits, so what the formula is 2 to the n, and with the n representing the number of bits, you must allocate the host ID to the network ID. So for example, if you're starting a network number that is in class C, so this is an example of class C. So the default subnet mask is this, which is your starting point. So the number of subnet you create is always in the power of 2. So if you need 20 subnets, so you must reallocate 5 bits. Because if you go with 2 to the 4, what is 2 to the 4? 2 to the 4 is only 16. So you could not accommodate 20 subnets in 16, but you could maximize it using 2 to the 5th by 32. So 20 subnets will be included in the 5-bit allocation. Okay, so that's the explanation why we need to check how many hosts we have. Now, for the third, reallocate bits from the host ID. So starting from the most significant host bit, that is from the left side of the host ID. So you must also make sure you have enough host bits available to assign to computers on each subnet. To determine the number of host addresses, you use this formula. This is 2 to the n minus 2. So within representing the number of hosts, 0 bits in the subnet mask. So as an example, we have use subnetting class C. So in this example, you have class C 192.168.1.0. So this is your IP address, and what you need is to subnet. Okay, and And take note. So you're given this example, and how many bits you have in this example. So example, given that you have 192.168.1.0, and your default subnet mask would be this one. And take note, if you have to compute, so you have 192.168, that would be this. So this is 192. And if you're going to calculate your values, so this is your third octet, first, second, third, and your fourth octet becomes this one. And with this example, so you going to add two ones in the fourth octet. So you have this cedar notation in your subnet mask only. So how many subnet you will have? So you have two. So 2 raised to 2, you have 4. So in this case, you have 4 subnets. And how many hosts per subnet you will have? So you have 2 to the n. So would be, so you have 6. So 6, 2 to the 6th. So you have 64. And after 6, you have to create your subnet range. So your first range is from 0 to 63. And this is your third, this is your fourth, and this is your third, and this is your fourth. Your subnets starts in this point, in this point, and this point, and the last part on this point. And what are the valid hosts? So if you're going to compute, so you have 64 minus 2, so you have 62 hosts on each. So take note, where do we get 6? Where do we get 6? Anybody? Where do we get 6? Sir, na nag-6 na da. So take note, the number of hosts will be always your number of what? Your number of zeros. Okay? And your number of subnets will be considered only from your fourth octet. So how many number of ones in your subnets? You have 2. So that's why 2. Okay? So this would have 4 subnets. And you have 64 hosts per subnet. So any questions with this? So this is only a sample given. So in the next example, we'll have another one. So answering the question of this, so we'll have this answer. So you have your 4 subnets, this first, second, third, fourth, and you try to present it in this way. So what you can see is you have the following answers for each. Now for this subnet, so you have the maximum subnet mask, and you have the range for each. So this is in 64. So as you notice, your range is 0 to 63 and your valid host is 1 to 62 and your broadcast address is on this one. So why you only have uh, 2 is missing because the other IP address was for broadcast address and the other one is for the network address. So this is your network address and broadcast address. So that is the 63 and 64 supposed to be for this subnet. So this is your 63 and 64. So you have valid host of 62 hosts. Now for subnet 2, so you have this number. So you have so your subnet starts this point, range of 64, and you have a valid host 65 to 126 and your broadcast address on this side. So you start your first address from this point and it was taken and also this one on the last part. And your subnet 3 would be this one also. So 192. So that's how you compute on each. So this is the solution. Normally, I will going to ask this in your module, and you're going to compute for this. Now, for your assignment 6, so you are given to create 60 subnets for class B address. That is 172.20.0.0/16. So the nearest power of 2 to 60 is 64, which is equals to 2 to the 6, meaning you must reallocate 6 bits from the host portion to the original subnet mask. So reallocating 6 bits from the leftmost of the third octet creates a subnet mask with a bit pattern of 111111100. So meaning, what will happen? So this would not be anymore 255.255.252.0. So if you have this as your third octet in your subnet mask, so you put this on your subnet mask and this becomes 255.255.255.2. Now you have this Cedar notation. Now, after this, you try to calculate for the values. So that's for your assignment. Okay, so there are steps in this assignment, so you need just to follow. And then you have this table binary. And another assignment. This is a class C. Okay, so why we are subnetting? So subnetting is a core skill required to understand the networks on the internet. So it is a simplified administration of computer network. So it improves security of computer networks, restructuring of internal networks without affecting external networks. So this ensures that traffic was destined for a device within a subnet stays in that subnet, which reduces congestion. Though through strategic placement of subnet, you can help reduce your network load and more efficiently route traffic, uh, provide logical representation of computer network. So these are the application of. As a summary to end our lecture today, so IP version for address is a 32-bit dotted decimal number separated into 4 octets. So this makes you 32. And every IP address must have a subnet mask to indicate which part of IP address is the network ID and which part is the host ID. So there are three main address classes. So these are class A, class B, and class C. So the address classes determine the default network ID and host ID portions of an IP address. So each class has a range of private IP addresses that can be used on the internet. You only use private IP if you use NAT. So you have the network access translation. So we have CEDAR largely replaces IP address class system. It uses a prefix number or subnet mask to determine the network ID and the host ID of an IP address. And subnetting enables an administrator to divide a large network into smaller networks that require a router for communication. It also allows an ISP to allocate only a number of public IP address and which requires a company. So instead of assigning the entire address class, so thereby conserving public IP addresses. Subnetting also allows dividing networks into logical groups for security and efficiency. There are several rules for IP address assignment. Only class A and B and C addresses can be assigned to a host. So every IP address must have a subnet mask. All host IDs on the same network must be unique. So you cannot assign a network number or broadcast address to a host. Computer with a different network IDs can only communicate through a router, and a default gateway must have the same network ID as the host. So that's it for our lecture 3. And I think we finished already.